on this computer. Okay. Okay. All good. So for those that are already with us, we're going to obviously wait until the hour, which is when we're due to start. So just bear with us for a moment. Hi, everybody joining us. We're due to start on the hour, so we're just going to wait for a couple of minutes just to let everyone join, and then we'll get started. So thanks for coming today. Yeah, I can see lots of people starting to join, so we'll just give it a minute or so.
Yeah, I think got to wait something like about 5-10 minutes.
Possibly not 5-10 minutes, but just a couple of minutes. Just to let people click on that meeting link. Okay, we're just waiting for a few people to join before we get started. Thanks for bearing with us for a second. Okay, I think we'll get started there so we can maximize the time that we have with Professor Sarkar today. And so I just really want to welcome you all to this webinar today. My name is Lara Mani, and I'm the working group lead. And today, this is the working group Past for Future, or Learning from the Past for the Future, part of the RISCAN network, which is one of the networks associated with Future Earth. And today we're going to have a wonderful talk from Professor Anindya Sarkar from the Institute of Technology in Kharagpur, India, on how monsoons and megadroughts shape the rise and fall of Harappan city Dholavira. I'm sorry, my pronunciation is not so great. So, but first, before we get to the webinar, I just wanted to introduce you to the working group team, as we've just taken over this working group from Felix Riades and a few from Aarhus. So as I said, I'm the working group lead. My name is Dr. Lara Mani, and I'm a senior research associate at the Centre for the Study of Existential Risk at the University of Cambridge, where I work on high impact, low probability risk events. And the working group co-leads, we have Arindam Chakraborty, who have both got their cameras on, and Everestus Lokal. So Arindam is a senior lecturer at the Department of Geology and Faculty of Science at the University of Malaysia. And Everestus is a master's student in environmental standards at the Joseph Sorwan Taka University in Nigeria. So it's our pleasure to welcome you to this webinar today, and to continue engaging with us as your new working group leads as we continue to create events and opportunities for us to engage as a community. We're really excited to be able to lead this and hopefully work with many of you coming forward. So just a real basic introduction there, and I'm going to pass over to Arindam, who's going to introduce our speakers today.
Hi, Lara. Thank you very much for the introduction of our group. So myself, Arindam, the co-lead of this Risk and Past for Future working group. So I, first of all, thanks to Professor Anindya Sarkar for accepting our request in a very short time. And I will be introducing you with some briefly. Professor Anindya Sarkar earned his bachelor's and master's degree in geology from Calcutta University, India, and later on PhD in stable isotope geochemistry from the Physical Research Laboratory, Department of Space, Ahmedabad, India. He served as a faculty member at Indian School of Mines, Dhanbad, India, and currently teaching as a senior professor of geology at Indian Institute of Technology, Kharagpur, since 2002. Professor Sarkar teaches stable isotope geochemistry and sedimentology, and also heading the Stable Isotope National Facility at IIT Kharagpur, India. He works in isotope hydrology, past and present climate change, and influence of climate, especially Indian monsoon, on past human settlements. Professor Sarkar is a recipient of INSA Young Scientist Medal and National Geoscience Awardee. He was a visiting fellow at Cambridge University, a JSPS fellow, and the Royal Society visiting fellow at UCL London. He was a visiting professor at Purdue University, Benjamin Meeker professor at Bristol University, and senior visiting professor at Academia Sinica, Taipei, Taiwan. He is a fellow of Indian National Science Academy and Indian Academy of Sciences, Bangalore. He has a H index of 28 and citations of around 2,400. Now I request Professor Sarkar to deliver his talk on how monsoon and mega droughts shaped the rise and fall of a Harappan city, Dholavira. I also request all of the participants to write their queries in the chat box, so that at the end of the session, we will get back to everyone with their answers from Professor Sarkar. Thank you very much. So I hand over to Professor Sarkar. Sir, can you unmute?
Okay, so good evening to everybody. It was indeed a pleasure to meet you all and give a talk on Dholavira, which is so close to my heart. I must thank at the onset Lara and Arindam for inviting me from the RISCAN group to give a talk on effects of climate change on societal collapse in the past. And when they approached me, I could not. I thought that yes, probably I can give some interesting information on which we have been working for last several years on Indus Valley civilization. So many thanks for introducing me, and let me straight away go to the is it visible? The slides are visible?
Yes, sir. Visible.
Okay. You see the reason that why the past records of climate change and their effect on society are important is obvious from the fact that look at the modern climate change. There are growing concern about the climate refugee crisis. In 2022 alone, UN estimates the shocking 32.6 million people who have been relocated. They call it internal displacements as a result of large droughts, wildfires, or heat waves, which are manifestation of extreme events in the current period of the climate change. And if you want to know that what would be the effect of these climate change on the society, one of the way to look at it is to look at the past records. As ages, IPCC has been always looking at the climate change over various time scale, from 1,000 years to century level time scale. So likewise, it's also very important that we look at what happened to our ancient societies about this climate change. Now, normally, if you want to look at the climate change, you look at the natural archives, and that gives you paleo-environmental reconstruction. You do certain amount of global and regional climate modeling. And on the other hand, the archaeologists, by excavation, they do retrieve the archaeological records. And then you basically link up the climatic effect on the evolution of the settlements or the evolution of the cultural strata as a function of time, and then try to see that how the people in the past tried to adapt with these kind of climate changes for sustainable development and planning. And if such a thing recur in the future, if some of those things can be adapted in future as well. So in a way, these are basically a link up between climate predictions in future vis-a-vis the sustainable development and planning. Now, if you look at the old world civilizations, there are various stages. I would be specifically speaking about the civilization of a very confined time space, that is of the Indus Valley civilization, which straddles both India and Pakistan, the subcontinent. But we have also similar kind of old world civilizations, the Yangtze River Valley in China, in the Mesopotamian region, as well as the Egyptian civilization. So all of these, if you look at the temporal record, they are all almost contemporary. That means they came up almost at the same time, and they collapsed also almost at the same time, meaning that there may be a kind of common driving force or forces which led this civilization to flourish, and eventually which led them this civilization to collapse after a certain period of time. Talking about specifically about the Indus Valley civilization, it has been bothering the scientists for a long time. A lot of work has been done. That what happened to the Indus Valley civilization. This is the left side is basically a map of northwestern part of India. The pink dots and red dots are nothing but the ancient settlements. This part is nothing but the big desert of Third. This area, in fact, is an hyper-arid area today. And if you go there, starting from its southern domain, central domain to the northern domain, you will be finding all along the periphery of this desert, large number of human settlement of this time exist. The right side is one of the very old settlements at Virana, the state of Haryana, during the excavation stage, where the settlement picture has been taken. Now, there have been many hypotheses why this civilization collapsed. For example, prolonged drought was one very favorite hypothesis. There were propositions that there were interpersonal violence, where large-scale burial have been found together. There have also been proposals that there had been infectious disease, something like leprosy and so on and so forth, and probably that also affected the settlement to a very large extent. So there are many different theories, but there was no convergence as such, because for convergence, what you require a kind of correlation across the time as well as across the space, and that was not found. Majority of the studies were kind of solo studies, dependent on individual records. Now, if you look at India, India has large number of such settlements across Western and Northwestern India. Of course, the historically recorded major settlements are in Pakistan. For example, all of you must be knowing Harappa, Mohenjo-daro, and so on and so forth. And after these two countries got independence, the archaeological surveys from both the sides, they have worked and excavated a large number of sites. If you look at India, the most excavated, well-known and spectacular site is at Dholavira, which is currently situated in a place which is hyper-arid, which doesn't receive rainfall, very harsh climate. Yet you find a fantastic metropolis which grew up during this time. And in 2021, 22, UNESCO had recognized Dholavira as the UNESCO heritage site, and in their citation they say that ancient city of Dholavira between 3000 to 1500 BC is one of the best preserved urban settlements in Southeast Asia. And if you look, I will give you some data. The settlement starts from pre-Harappan period to late Harappan period. So it has a long temporal record, which is usually not found in many places. Most of these settlements, either you will be finding, they are found in piecemeal. Either you will be finding the early Harappan, or you will be finding the mature Harappan, or you will be finding the late Harappan. But finding out a continuous settlement at a single site like Dholavira was really rare. And that is what kind of motivated us to look at what could have happened to the Dholavira, so that these spectacular old world megapolis developed here, flourished here, and eventually declined towards the end of Harappan civilization. This is basically a picture of when the excavation at Dholavira was going on. As I have written here, that excavation went for long 50 years. From 1990 it started, and it continued up to 2005. These two gentlemen who were celebrated archaeologists in our country, J.P. Joshi and Dr. R.S. Bist, they were the principal architect of excavation of this site and finding out the record of archaeology at Dholavira. Now, if you look at these maps, the left-hand side is a rather generalized map of the entire subcontinent, the western and northwestern part. This is the river Indus, along which you will find large number of settlements are there. There are large number of settlements in the northern India also. And also there are large number of settlements in what we call the Gujarat domain, where the Dholavira also exists. Now, if you look at the rainfall pattern, you will see that these white dotted lines are nothing but the rainfall isohedge. So you go from a semi-arid to arid to something like, something like hyper-arid, what you call region, where the Dholavira actually exists. Now, this one, the lower picture will tell you that what is the landscape today. You can see that there are very low kind of marshy land. Rainfall is virtually negligible. Only during the monsoon time, you get something like 200 millimeter or even less rainfall. So locally in India, they are called as the white desert because whenever these water is accumulated and eventually they're evaporated, they form salt encrustation in this region, a spectacular landscape indeed. The question, of course, obviously arises that today's climate is so harsh. What made these people at Dholavira to establish this city and evolve in a great megapolis that eventually collapsed towards its end? Now, what I have done today in today's talk, I thought I will briefly go into some of the interesting facets of Dholavira from archaeological viewpoint, and then go over to reconstruct what could have happened of these settlements to time. Inherently, I must tell you one thing, that although in science, the biasness is not desirable, but when a scientist works through the results what he obtains, he or she obtains, some kind of biasness inherently develops. In case of the geoarchaeology, where people are trying to study the archaeological settlements, ancient human settlements, and trying to find out the hosting factors of their evolution, you can broadly categorize the scientists into two. One is in a way called the climate determinist scientists, who believe that climate had very strong influence on the human settlements and their evolution or the collapse. And the other group, which thinks that the climate may be an important part, but climate is not the sole deciding factor. Social dynamics also play a very, very important role. By virtue of the fact that I have been working on past climate change from a very long time scale to 1,000-year to century time scale, or even modern, you may say that I kind of belong to the first category of people, that I believe that climate plays a very, very strong influence in the evolution of the human settlements. And that bias has also been because in the geological record, if you look, the evolution and extinctions of the organisms have been quite a large, influenced by the climate change, sea level changes, and so on and so forth. Anyway, so if you look at the Dholavira, this is the mound of the Dholavira. What you see that this one is the fortification wall. The whole city they built up within a wall. That means they needed some kind of security, and inside the wall, the city grew up as a function of time. If you look at from the top, the city has very conventional, domain, like the central castle, where probably the most influential people were living, followed by the bailey, where probably some artisans were living, middle town, lower town, and all surrounded a number of water reservoirs. What you also find in water reservoirs in the Mohenjo-daro and many other places. Now, this kind of layout of the town planning are so typical for almost all the Harappan or Indus Valley civilization sites. So Dholavira is no exception. It's very interesting that the people so far away, either in the Pakistan, in fact, if you go to the Western domain, the Indus Valley civilization has been found even at the bank of the river Amudarya in Afghanistan. And in the eastern side, you find as east as, for example, in Haryana, Rakhi and Birana, and in south, as I said, the Gujarat domain, you have Dholavira and many other sites. But in each of the sides, wherever they made a city, smaller or bigger, the town planning was kind of similar, meaning that their architectural concept, the construction of the cities, the knowledge base were kind of, spread across the subcontinental landscape. Very interesting indeed. And if you look at this landscape, you see that they built up the city within two rivers. One is called the the river Manhar, and in the western or northwestern side is called the river Mansar. These rivers today do not have water, but if you go to the field, you see that these rivers must have been flowing very strongly when they built the city, so much so that they had developed the check dams on the cities. This is what you call the river, one of the river Manhar, where you can see that it's almost dry. Some muddy slush water comes when little bit monsoonal rain comes in this region, and that's about it. And if you look at the inside of these castle, what I said, where the most important people were living, this is the entry gate of the east, where you can see the castle pillar elements. Probably there was a gate which was being closed, and this was the entry point to the city. If you look from the top, they have very well planned what you call houses. They have arterial roads. They have what you call excellent water management system, from dug wells, the water tank, to even extensive drainage system. So much so that even they had reconstructed manholes. So you can easily imagine that the architecture of the city was very, very advanced in its management. If you go further, you see that almost like Great Bath of Mohenjo-daro, Dholavira also had large reservoirs. You can see the steps here to which they were coming down. Probably this reservoir was being used as a kind of step well during the low water time. Probably the water level was going down and they were coming to collect the water from the deeper region. And during the good monsoon time, probably these reservoirs were being filled up by the water so that they can utilize for the daily use in the city. If you look at the archaeological materials, fantastic pots and the potsherds have been recovered from Dholavira. I don't want to go only thing just to tell you that these pots and the potsherds are used by the archaeologists to classify the different Harappan phases. That means the early type potteries are different than the mature Harappan. Mature Harappan are quite different than the late stage Harappan. And their evolution also tells that how creative they were, or when they were not being able to make good potteries, meaning that there is some telltale signatures of the what you call the climate or whatever you call the bad times on the archaeological artifacts. They also had a variety of ornamental bits. Probably the women or even the men were using them. Carnelian, Amazonite, mudstone, lapis lazuli. They had large number of seals which are found in many ancient cities of Indus Valley civilization. Bangles, human figurines, and even very precise weight. So all of these indicate that it was a fairly advanced human settlement with all facets of almost like modern human settlements. Because these were the Bronze Age settlements, they have also extracted large number of Bronze Age metal objects starting from copper crucible, fish hooks, spearheads, lead and gold ornamental materials, and even as you can see in the left side, they have found out silver coil. I do not know why they were using this coil, but there must be some advanced uses. There have been some work based on lead isotope from where they brought this copper, because the vicinity there was no copper mine as such, but the provenance analysis by isotope suggests that probably these copper ores were brought from far-off mines of Gujarat, Haryana, Rajasthan, where there are active copper mines are there, or even the provenance study says that they were brought from Oman, where also the equivalent settlements were there. With them, these Indus Valley people had strong, trade exchange throughout the Indus Valley civilization time. This is the man's oldest signboard made in mineral gypsum, because the script is undeciphered, so no one knows what does it mean. It has also been found that there has been large number of burial mounds with offerings, large number of cemeteries, and that indicates that after their death, they were very meticulous, almost like Mesopotamian or other civilizations, to bury their dead bodies with a lot of rituals, after the death. Now, as I mentioned, that this is a desert region. Dholavira is occurring on the top of the mound. All around, there is no freshwater bodies. In the northern part, you can see the hot desert. How did they build such magnificent city in the remote desert? That was one of the key questions we wanted to basically address. That what led them to build this city? To do that, a team of workers from Postgraduate Archaeology Institute of Deccan College, Pune, Physical Research Laboratory, Ahmedabad, Kachchh University, and IIT Kharagpur landed nearly something like 8 or 9 years back. And since then, we have been working in this region, looking at the various aspects of these settlements. Now, in archaeology, as we know, the first thing what one does is radiocarbon dating. This radiocarbon dating is accelerated mass spectrometric dating. This is the top is basically at Physical Research Laboratory, Ahmedabad, the AMS Radiocarbon Lab, which is our backbone of all these archaeological dates. And one can date a variety of material, whatever is found. It can be cereals that are carbonized. It could be the bangles, which are calcium carbonate, or it can be even the shells, which are found in these archaeological settlements. So basically, this becomes a very important input as far as the chronology reconstruction is concerned in an archaeological site. The second one is, of course, the dating the potteries by optically stimulated luminescence. And these OSL dating basically talk about the time since the last heating was done to these potteries when they were being baked while making these potteries in this settlement. And then, of course, finally, we try to use the isotopes. Once we know the chronology, we try to use the isotopes of a variety of kinds to study the past climate change, the food habits, and so on and so forth. Okay. Now, if you look at the samples, what one gets in the archaeology are a variety of samples. For example, one gets bones and the teeth. These are examples of the deer teeth and the cattle bone. One can extract the phosphate, measure the oxygen isotopes from the phosphate. One can also find out the molluscan shells, something like this, and measure the oxygen isotopes in the molluscan shell. One also gets very tiny, about centimeter or even less, size the ear bones, which are known as the fish otoliths. And depending on the time scale, one can basically use these for climate extraction or the change of the climate in the past. What does this isotope research tell us? If you look at the hydrogen and oxygen isotope, they talk about the past climate, meaning rain, drought, temperature. They also talk about the migration. Where did people come from? If you are talking about the carbon isotopes, that will tell us about the paleo diet, what Samuel Epstein used to jocularly say that you are what you eat plus few per mil extra. And of course, when you try to analyze the carbon, nitrogen, and oxygen isotopes, you can also try to establish the kind of food chain depending on the food source which were being utilized for these human beings. Now, what I will be talking today, a very specific thing. We have done a variety of studies starting from carbon isotopes, hydrogen isotopes, oxygen isotopes, but I will not talk all of them. I will be only talking about the use of oxygen isotope for tracing what you call the tracing the climate change. Now, those of you who know a bit about the isotope systematics, they know that the global hydrological cycle determines the relative ratios of heavy to lighter isotopes of oxygen in the water, meaning that the evaporation and corresponding precipitation from the clouds make the fresh water much more negative, while the ocean water much more positive. And this makes the two distinct reservoirs. So therefore, one can basically talk about the water source, whether it was the fresh water, marine water, glacial waters, by studying the water isotopic composition. Plus, there is something called amount effect, which all the isotope climatologists more or less are accustomed with, is that more the rain, the negativity of the oxygen isotope increases, and if you have a less rain, the negativity increases, known as the amount effect. So basically, by using these, one can retrieve the past climate, provided the materials which are found, they have grown in all of these water systems. That means that if an organism is growing in the ocean water, it will be recording the climatic signals in the ocean water. If a material is working in the fresh water, it will be recording the climate signals of the fresh water. If a material is growing in a glacial meltwater, it will be recording the climate signals of the glacial meltwater. In fact, today we have such fantastic database that we have monthly variation of the precipitation of isotopes across the globe. The color codes clearly tells you that how basically the oxygen isotopes in the precipitations are changing over a monthly basis. In India, for example, during the monsoon time, the oxygen isotopic compositions become extremely negative, whereas in the non-monsoon time, when the monsoonal rainfall is rather low, excepting the northeast winter monsoon, which affects mostly in the eastern coast and northeastern region of India, the water is relatively enriched as far as the oxygen isotopes are concerned. So one can basically use the oxygen isotope to test the climate in the past, and that is what we have also used in the case of Dholavira. Now, how does it work? If you look at the mammalian bone, tooth, a molluscan shell, or even an otolith, delta 18O, they basically can be equated with the drinking or the ambient water delta 18O. Because the drinking or ambient water delta 18O is dependent on the rainfall delta 18O, so these archives, they will be basically helping us to retrieve the paleo rainfall, both amount and the time. Now, if you look at the bone, if you just analyze the bone, you will get an integrated kind of rainfall assessment over the lifetime of the animal. But if you want to go to the seasonal scale, you have to go to a much, much finer interval. How can one do that? For example, if you look at these kind of shells, if you cut to them, you will be finding the growth rings which grow to the seasons. And if one has the ability or the technique to analyze these individual growth rings in terms of their isotopes, one can also retrieve the seasonality variations of these. So, for example, if you look at if you make a cross section and make a poly section, these growth rings can be very uniquely found, and if you can analyze each of these successively, they will be giving rise to this kind of wriggles, which are basically, the seasonal wriggles what you find in the normal climatic system. The problem with this, of course, these growth rings are so tiny. Normal experimental technique which employs drilling and things like that does not work. So at IIT Kharagpur, we had to develop a technique where one can shoot a very tiny, about 50 micron laser beam to generate the oxygen from there and measure it for their oxygen composition, which is shown somewhere here about the laser system which we have developed over a period of time. Anyway, now if you come to Dholavira, as I said that when we started working virtually, there was no chronological constant of the Dholavira. There are only 1 or 2 dates, and therefore the first thing what we did is basically chronologically constant. If you look at Dholavira, there are 7 cultural stages from the beginning of the settlement to the end of the settlement. This is the beginning, the lower part is the beginning, and at the end part, the 6th stage is basically the last stage, after which the entire place was deserted, and then again they come back. But when they come back, these people were not as developed as the people below. They were more like pastoralist people. They were not urban people. So this was a time period when something drastically happened. If you look at the absolute time scale, somewhere around 5,500 years before present, the settlement started. In fact, there are settlements even below, which the archaeologists call them as the pre-Dholaviran culture. From this time to something like 4,300 years or so, the city rapidly developed. When I say rapidly developed, means they were expanding the city. They were making the domains of the city, as I showed in the Google map. They were building the reservoirs. All kinds of activities were going on. But something happens when it comes to somewhere around 4,300 years back. The city maintenance was not being done. There are many archaeological evidences. The artifacts, that is the potteries which they were making, they were not very advanced kind of potteries, and the expansion of the city stopped. So in a way, following this rapid expansion of the city, somewhere between 4,300 or so, around this time, the cessation of the expansion happened. And by the time it comes to after another 100 years, 4,200 to 4,100 years, city almost nearly collapsed. That means all the reservoirs were abandoned, the settlements were abandoned, and there was no virtual activity much within these time period, 4,200 years to 4,000 years or so. Although the settlement continues up to 3,800, 3,700 years, virtually no activities were going on in the city till they were completely abandoned at the end of stage 7, that is at the end of 3,800 years or so. So this is what, as far as the temporal evolution of the Dholavira is concerned. So therefore, we wanted to know that why they built and why they collapsed or declined. Now, interestingly, if you go throughout the Dholavira section, you find a variety of biological material, or in other words, called the bioaccretionary material. One of them are these gastropods, which are known as Terebralia palustris, which are typically formed in mangroves. As you can see in the picture, these are almost live gastropods which are forming in modern day mangrove of Gulf of Kachch. Left side the picture is a Terebralia palustris from the early Harappan of the Dholavira. You see they have been nicely cut. This is a human cut, and the interpretation of the inference is that they were being used for food source. They are also a major food source for many communities, coastal communities even today, both across the Arabia, southern coast of Pakistan, western coast of India, and they were the major food source even during that time. Very interesting thing happens. If you look at the entire sequence, these gastropods are found aplenty along with the fish otoliths and bivalves in the Dholavira. Many such shells are burned, indicating that they were cooked. Concentration of the shells were highest in the early to mature Harappan, and the concentrations are less towards the later part of the Harappan when the city was getting kind of declining. There was no maintenance of the city, so we also find not so much of such shells in the later part of the settlement. But one of the key questions we have been asking, that if they are the mangrove kind of dwellers, these organisms, say you do not find any mangroves in the nearby region. The only mangrove region which occurs today is something like about 100 kilometers away, which is either the Kori Creek or the Gulf of Kachch. And because they were using them as a routine, food material, quite but obvious that they must have been collecting it from some nearby region. Certainly, they will not transport as a daily food source from 100 kilometers away, especially in a situation when they did not know how to preserve the food. So what was the landscape and what was the kind of climate? In order to do that, what we did, we basically measured the salinity oxygen isotope ratio in the Gulf of Kachch, collected a live modern Terribralia palustries to see that if they are recording these salinity and the temperature of the Gulf of Kachch Bay, if they are reliably recording today, it is safer to use these as the tracers of the Harappan climate through the Harappan times. The fundamental principles are very clear that these are basically calcium carbonate shells. As they grow, the calcium carbonate and water, there is an oxygen isotope exchange. The fractionations are such that the carbonates incorporate heavier isotopes. And by measuring the carbonate isotopes, one can differentiate whether the water in which the shells are living, they are seawater, they are freshwater, they are the glacial meltwaters, because they have distinct, isotopic domain as far as the composition is concerned. Second, if you are measuring the isotopes along their growth, you can also talk about the periodicity or the seasonality during that time, and that will indirectly tell you about the strength of the past monsoon. So what we did is we analyzed modern Terribralia palustries from the Gulf of Kachch. This was the work of a graduate student, Tosha Sengupta, who is now doing postdoc in University of Exeter in the climate change program. But this is what basically you get the seasonality cycle. What does it mean? You see that there is a positive peaks and there are negative peaks. Basically, the low values are coming from the periods when the shells were growing in a water, when the monsoon runoff was high, okay, temperature was relatively higher, and the delta H value was much, much lower. On the other hand, during the non-monsoon time, the temperature was low, especially the winter time, temperature was low, the water values were positive, and therefore the shells were accordingly growing. So if these shells, for example, this shell probably had grown 1 year, 2 year, little, about 2.5 years of time this shell had grown. Then the second thing we wanted to do, if these observed variabilities match with our predicted variabilities, which are found in terms of the salinity and the oxygen isotope of the Gulf of Kachch. And when we do that, we see that indeed they match. These envelope is nothing but the brown data points are the predicted data points. The envelope is the error spread of this data point. But clearly it shows that peak-to-peak matching is that the absolute amplitude of the modern day which you observe in the Terribralia palustries, they are consistent with our predicted values, and therefore this can be probably safely used for inferring the past climate during the Harappan time. There were other kinds, as I said, that there are fish otoliths. So therefore, we collected the fish from the Gulf of Kachch, extracted the otoliths, polished them. As I said, that these are very tiny growth rings. So therefore, we had to develop a technique which is a laser heating, which can do a very fast as well as reliable, what we call isotopic analysis, giving rise to the seasonality during the time period. If the fish was living for about 1 year or 2 years, you get a seasonality of these fish during that time. And this is what is an early Harappan otolith. You can clearly see the growth rings. So what one does, one shoots the laser across the growth ring, therefore one can get what you call the seasonality during the settlement period. This is what basically, this is what is the early Harappan, 4,700 years old Cerebralia palustris. This is the seasonality we go, and the kind of values we see is something like this, -6, -5, and things like that. And these are the early Harappan mangrove estuarine water. Just keep this in mind. When we look at another bivalve, for example, which is essentially a freshwater bivalve, not a mangrove, that means brackish water gastropod, this gives even a very interesting picture. The seasonality values are such that it gives something like -9, -10 kind of values. Okay. Compare these with the modern rainwater values, which is something like -5. The paleo water reconstruction shows that the Harappan water was something like as low as -7, -8 kind of values. This can only happen if one considers the amount effect, that the precipitation where today is less than 200 millimeters, in this region, precipitation would have been at least 600 millimeters, if not more. We also did another very interesting exercise. We tried to do some back of the envelope calculations. These calculations shows us that only the monsoonal water in these early Harappan landscape was not sufficient to explain the observed values we were getting. It demanded another input of the water, which must have been sourced at these regions or these mangroves in the early Harappan times, which had more like Indus-like water, or in a way that the glacial belt water was coming into these mangrove regions in the southern part of the third desert. Very intriguing indeed, because today these areas do not have any rivers. Today you do not find any river is debouching in this area, excepting vestiges of some rivers which have almost been dried up. So if you look at these, no peninsular or Himalayan foothill rivers, which are mostly monsoon dominated, has so much of depleted values which have been observed in the early Harappan shale values from the Dholavira. Only the Indus-like glacial meltwater discharge during the summer monsoon months to early Harappan floodplain mangroves would explain these kind of situations. Now, a kind of picture we surmise is something like this, that where even today the communities collect this kind of shells from mangrove region for using them as a food source. Abundant mangroves were there. The riverine landscape was very strong. Not only us, number of workers from different institutes have also predicted that the fluvial landscape of the Harappan time was quite different than was today. So all in all, the interpretations we made is that the isotope data suggests presence of a strong monsoon between 4,700 to 4,400 years back. Strong riverine system, extensive mangrove near the sea river confluence. Mangrove water was brackish, the mix of sea and river water in which those gastropods were thriving, and river water had significant glacial meltwater in which the freshwater bivalves were growing. And Dholavirans built the city and expanded it during this period of excellent climate that helps in large-scale rural agriculture, a kind of artistic view one may like to draw something, like paint something like this. Okay, that very good agriculture, thriving market communities, and so on and so forth, which was occurring during this early part of the Harappan civilization. In a way, when we look at a kind of reconstruction of the fluvial landscape, we say that this is the Indus River Valley. This is so-called ancient river system. Some people call them as the Saraswati river system, as depicted in some of the mythological scripts of the Indian, mythology. And in reality, we also have river systems which are known as the Nara, which are connected to the Indus River. And even today it flows. Only thing that these are being impounded at the India-Pakistan border. But basically, during this early Harappan time, probably these estuary was much more expanded. And it was a kind of estuary, one may name it as a Indus-Saraswati estuary. But Peter Clift believes that these estuary probably expanded much in the eastern side. And I think that is a very fair kind of assessment of the expansion of the estuary. And therefore, Dholavira being situated here, they must have been basically collecting the materials in these estuary mangroves for their daily food source. When you come to the later part, that means 4,300 years to 4,100 years, something dramatically happened. I would just like to draw your attention to the calculations of the waters from the shelves. Look at when we were getting the water values of -7, -8 during the early part of the Harappan settlements. When you come to these 4,300 to 4,100 years, we have multiple shells, multiple archives from otoliths, cerebralia, bivalves, and so on and so forth. The values are something like -2, -2, -1, extremely rich, even when the monsoonal circulations were stronger. That means in seasonal landscape, when little bit of monsoon was there, that monsoon no way was comparable with the monsoon during the early or mature Harappan time. Meaning that there must have been very large scale evaporation was going on. The total amount of rainfall might have decreased, and the amplitude has also decreased considerably. So the seasonality which we find in the early Harappan with a large amplitude seasonality gets stunted during the later part, when archaeologically we also see that city stopped expansion and the city is almost on the verge of desertion. So extreme drying of the pre-existing river courses we inferred. Probably the landscape changed from a good, humid riverine landscape to hyper-arid region, and the estimated paleo precipitations could not be more than 300 millimeters or even less during this time period. So if you look actually these time periods, 4,300 years to 4,100 years, is very interesting because it coincided with the so-called Meghalayan stage drought, which has been designated as a kind of nearly a global drought, which had prevailed not only in the tropics and the subtropics, but beyond. So, if you look at the Meghalayan age, where the geologists gave this Meghalayan age very recently a separate category of geological time scale, although there are some people who do not believe that it is a global phenomena, whether global or not, high latitude, whether it had affected or not, that may be a subject of further investigation. But definitely, this was a pervasive event covering the entire tropics and the subtropical region that affected the human settlement. So
I ask you to wrap up now, please. Sorry, Professor Sarkar. We're coming up to the hour.
Yes?
Oh, we need to wrap up now. Yeah, sorry.
So we had a major drought, and today's understanding from the speleothem data is that these droughts probably was not only one, but they were recurring droughts, each spanning something like few decades or so. And the landscape we infer is basically the entire riverine system got dried up, and therefore the city of the Dholavira also deserted. Now, one important thing, as I mentioned, that what was the riverine system? This riverine system in the landsat imagery, as you can see here, the black patches are buried paleo channels, which are being conjectured as these paleo river channels, which were debouching into the Rann of Kachchh. So if this is the river Indus, these are the Nara canal which is flowing today. And today, if you go to the Indo-Pak border, you will see that the Nara river is almost dried up, only impounding, giving rise to lake-like situations and things like that. Interesting thing is that when the Dholavira collapsed, it is not only the Dholavira, all the settlements across the Indo-Pak subcontinent collapsed. These are the compilation of the radiocarbon ages. And as you can see that somewhere around 4,300 years to 4,000 years, almost all the settlements had actually declined during this time. And it is not only the Indus Valley civilization, the Yangtze River civilization, Mesopotamian civilization, Egyptian civilization, all of them simultaneously collapsed. And if you look at some of the publications of Harvey White long back, you see even the high resolution lake, marine, and the speleothem records also indicate abrupt aridification and linked collapse of the Akkadian Empire at Tel Lilian, Syria, and so on and so forth, suggesting these as a global event. Whether it is in the Habur plain of Syria, whether it is in the Egyptian settlements, or whether it is in Dholavira, all show a very strong perturbation of the climate, giving rise to an abrupt aridification within a very, very short period of time. What caused this aridification, we just do not know. One of the things is probably the end of the Green Sahara, as some of the modern, modeling studies say, that probably the green vegetation of the Sahara abruptly collapsed, increasing the aerosol input, thereby disturbing the Hadley cell and corresponding the monsoonal circulation. But these are the areas where very strong modeling work is needed further to arrive at a right kind of conclusion. So what gives? If you look at the predictions of the IPCC, we know that the prediction is that the drought and the crop failures are going to increase over a period of time. The continuous greenhouse gas emissions would induce many changes, including the number of hotter days by the end of the centuries. And what we think, by looking at the Dholavira and contemporary civilization, probably they present classic cases for understanding how climate change can increase the future drought risk, as predicted by several working groups of the IPCC over the last several years. Where did the Harappan go? If you look at the early Harappan, these are the settlement patterns of the red dot. All of them, they basically shifted towards the eastern domain, where the monsoon was strong, either towards the Indo-Gangetic plain or towards the southern side. For example, in the Dholaviran region, where the migration was either in this direction or in this direction. But all in all, there had been a major migration of these Harappans. And indeed, we found out small settlements in the periphery of the Thought Desert, somewhere around the early Iron Age, 3,000 years before present, or 3,200 years before present, when the second urbanization takes place after the collapse of the Indus Valley civilization. And these suggest that this intervening time period between the first urbanization, that is the Indus Valley civilization, and the second urbanization, that is the Iron Age period, there was a large-scale human migration over this region. How this migration happened? What was the route of this migration? Where did they go and how did they settle? The matter of future research. And what we are trying to retrieve in our current study is trying to do extensive drilling in the Rann of Kachchh, in the Dholavira, to ascertain that what kind of climate actually, occurred post Indus Valley civilization, so as to retrieve the relationship between the climate, post Indus Valley climate, and the advent of the Iron Age, what took place in the northern part of India, as well as the Gujarat region, or in the other parts of India. So I would stop here today. Before I stop, I must thank my collaborating institute. For example, we got a lot of support from BST, Council of Scientific and Industrial Research, Infosys Foundation, who had a variety of collaborations from Deccan College, PRL, University of Haifa, where we did small work on the Mediterranean archaeology. And of course, we have a large number of collaborators across the institute, starting from what you call Archaeological Survey of India, PRL, Deccan College, Kachchh University, Calcutta University, and a host of what you call graduate students from IIT Kharagpur who had been very actively working in this project over the last, about 8-9 years or so. Thank you very much. So if you have any questions, I'll be very happy to answer.
Thank you, Professor Sarkar, for your enlightening talk on the Dholavira. The first of all, I have a question from the chat box from Saikat Das. Near of Dholavira had any site of silver for making silver coil, as you already showed us silver coil in your presentation. So Saikat is asking for that.
Yes, there are. I showed the picture.
So he's asking from, is there any site nearby or where from the silver you have been?
These artifacts have all been found while they were excavating in Dholavira. See, Dholavira is, I think, if you look at the aerial extent of the Dholavira, it would be 5th largest among all the Indus Valley civilizations. If I remember correctly, 76 hectares or something like that. And the excavation was limited to the present site. Although many archaeologists believe that there might be sites away from Dholavira, but all the materials which I showed some of the example pictures, they have all been obtained while the excavation was going on for that 15 years between 1990 and 2005, from bottom to top. So the silver coil also came from those excavations. Many of these are actually exhibited in the Museum of Dholavira, and much of them are exhibited in the National Museum at New Delhi.
Okay. So anyone else from the participants want to ask Professor Sarkar? Can directly unmute and talk. Lara is asking that what mechanisms do you believe would have driven such an extreme monsoon?
You mean to say the early part of the Harappan, the strong monsoon?
Lara, you can speak up. Yes, she is telling yes.
Okay, so no, that early monsoon, the early Holocene, is essentially solar insolation driven, because it is very well known. For the last, if you look at the last 10,000 year record, the early Holocene, somewhere between 11,000 years to about 8,000 years, the monsoon over the Indian subcontinent was very, very strong. And this is precisely because of the solar insolation was very high during that time, and that actually triggered the stronger ocean atmosphere circulation, and therefore the monsoon was strong. So that is fairly well understood. What was not understood, that why the monsoon went down. That is a very, very active field of research. Does that answer your question?
Yes, thank you. Yeah.
Anyone else from the participants want to ask? If not, I have one question, Professor Sarkar. I just want to know if you, as you mentioned, that the area is mostly mangrove and estuarine type area. So does in the archaeological site you have some, as you have shown some fish hooks or some there, but you have any boat materials, like from where they go for fishing or something like those things?
If I remember correctly, see, fish otoliths are abundantly found, which we have analyzed and whose seasonality record I have shown. Okay.
Yeah, but any like material, fishing materials?
the archaeogeologists have also found out fish bones there. Yes, there.
Oh, okay. Because similarly, I was just after arriving in Malaysia, also in the cave sites of Sabah in the northern Borneo side. So we have some settlements in the cave. So they were also using those similar type of molluscans, and they used to break those heads, and they used to eat lots of shells in the caves, actually cave sites. So they were using the similar types of food habitats. Maybe it was around 1,000 years ago, actually, not too far, but we are also having here. I was just saying.
Mhm.
So, and
Yeah,
also yeah.
because these were see, probably the landscape. There is no record of how the sea level would have been during the early Harappan time. There are only conjectures that probably they were kind of having boats, etc., etc. But there is no type. There is a graduate student who is working with us, who is trying to study the organic geochemistry of the subsurface of the Rann of Kachchh. Once they are there, probably we'll have some idea what kind of relative sea level changes are there. But pending that, no idea about the sea level around this Rann of Kachchh region during the early period. But in all likelihood, the very fact that the entire settlement has enormous amount of these mangrove shells, the fish otolis, the fish bones, they suggest that they could not have been very far. They must have been almost like a coastal communities, okay, who were thriving in this.
Yeah, and the last question I want to ask, the rice grains that you got from that place are anything like it was near to the estuary, so maybe the saltwater intrusion was there. So the variety of rice they were growing were similar to our present and near to the saltwater areas. Any idea?
Uh, I personally will not be competent because the grains which have been found in Dholavira, I have not studied. I am not aware about that anybody has studied. So I
So
won't be able
those
to.
were mainly the wild rice, like
I
those
don't know.
species.
I
Oh, you
can't
don't know.
say.
Okay,
I
okay, 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 okay.
ventured into the crop pattern actually.
Okay, 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 okay.
No
Okay.
study. There are study of the crop patterns from other nearby sites. For example, if you look at the site like Kuntasi and others in the nearby region, they have particularly the Birbal Shahani Institute of Paleosciences. They have reconstructed the crop pattern, and what they showed that when the monsoon was good, they were growing rice and or water, water. The crops which grow which require a lot of water. But
Most
when the
water.
monsoon occurred, they switched over the crop pattern. The water resistant crops were there, like millets and things like that. So that is there, but not at Dholavira and other places that has been recorded. Yeah, the whole community across the landscape changed to the crop pattern.
Okay, okay, okay.
Yeah.
Thank you, Professor Sarkar. If there is no other questions from the participants, you can always contact Professor Sarkar at his email ID, and this his recording will be there in our Rescan and website, so you can later on connect with him at aninda@gg.iitkgp.ac.in. So thank you very much, Professor Sarkar. If Lara want to add something at the end.
No, just a massive thank you for everyone joining us today. I've also put a link in the chat to join the RISCAN mailing list for our Past for Future group if you're interested in more events and information from our working group, or you want to participate any further. So a massive thank you for everyone today, and we'll close the webinar there. Have a lovely afternoon. Bye.
Okay, so goodbye, everybody.
Goodbye.
Good
Thank
night.
you, Professor Sarkar. Good night.